Good day. Warm welcome to this beautiful Thursday. Then we meet again. Today we'll be doing Euclidean geometry, grade 12. Welcome to Yebo Tutor. My name is Vuyani, and I'll be taking you guys today for mathematics, grade 12, Euclidean geometry. We'll be doing Euclidean geometry. If it's your first time to join in, don't forget to subscribe, to like and comment, so that you can have an interactive session, so that you can be able to engage together. Without wasting much time, let us now start with our session today. I am ready. Are you ready, guys? Okay, great. I'm gonna start with an overview. First, what is important is for you to know that this is grade 12 Euclidean geometry. It's building up from grade 10 and grade 11 work. But what is most important is grade 11 work, which is the theorems, theorem 1 to theorem 7. You must know your cyclic quads, Chord theorem, all those theorems which were taught in grade 11. They are so essential and they are so important. Midpoint theorem as well. It's also important. So please bear in mind that those theorems which you are taught in grade 11, they are a building block for what you must be able to know. They are your monomers for what you are supposed to know for your grade 12 work. So today we'll be focusing mostly on the proportionality theorem as well as the similarity theorem. So I'm just going to give you a small overview of this section. So first of all, I want us to know and check and revise. I want us to revise and check and take a look at the proportion. I want us to take a look at the proportion and area of triangles first. I'm just going to give you an overview or a small summary of grade 12 work. So now we have what we call, number one, we have what we call a ratio and proportion. So what is ratio and proportion? So like I want us to just highlight ratio and proportion. Ratio and proportion. Great. So now ratio compares two measurements of the same kind using the same units. So in other words, in order for us to be able to perform the ratio, I'm trying to say that we are comparing two measurements of the same kind using the same units. So this is so essential that you understand that we have the mind and we have to understand ratio and proportion. And we are saying that ratio is to be able to compare two measurements of the same kind with the same units. So now I want to just make a small example, e.g. maybe if line A is equal to 2 units long and line B, okay, is 6 units long, determine the ratio of A is to B. So how do you determine that case? Let me just draw something. For instance, we have this is our line A, which is 2 centimeters. This is our line B, which is 6 centimeters. So now my question is determine the ratio of these two lines A is to B. So the ratio of A is to B is the same as 2 centimeters is to 6 centimeters. Do you see something? We said ratio is to compare two measurements of the same kind. These are both digits. These are both numbers 2 and 6. They are of the same kind and they have the same units. So the both units which we have here, it's centimeters. They are both in centimeters. So basically what we are saying that ratio, we are comparing two measurements of the same kind. Both of the numbers, they are numbers. And they have same units. So in simplified version, we know that we can divide both sides so that you can have a simplified ratio. So when we divide by 2, we end up having 1:3. This is our ratio. But ratios can be written in form of fraction. So if we're having A is to B, it is the same as A over B. We can be able to write ratios in a form of fraction. So what do we have for the value of A? We had 1, and what do we have for the value of B? We can write them in the form of fractions. Now let me just give you another small example number 2. Example number 2. Now let's say I give you, so line C is 1 centimeter, and line D is 3 centimeters. To illustrate them, this is line C. This is line C, which is 1 centimeter. This is line D, which is 3 centimeters. Then they say, write down the ratio of C is to D. Now, this is my question which I just made for you guys. So now they will tell you that, okay, we are having line C, which is 1 centimeters. It's a vertical line. And we are also having line D, which is 3 centimeters, which is also a vertical line. Now they tell you, write a ratio of C is to D. We know that C is to D is the same as 1 is to 3. Do you realize something, that the ratio of C is to D? Oh, also we know that ratio, we can write ratio in a form of a fraction. Do you realize that A over B is equivalent to C over D? So now, since they are equivalent now, so we're saying that these two, then A over B is the same as C over D, because both of them, they are equivalent to 1 over 3. So since both of them, they are giving us the same result, the same answer, which is 1 over 3, then we can be able to conclude that these two, they are equivalent to each other. So just like right now, so the two ratios are equal, and we can say that they are both equal to each other. As we can see here, they are equivalent to each other. So now we can now write A, B, C, and D. Now we can now write A, B, C, and D in different ways, so that are in proportion. So now we can write this proportion, because this is illustrated as a proportion. So we can write this proportion in terms of different ways. So we can have A over B. Number 1, we said we have A over B is equal to C over D. Number 2, we can write as B over A is equal to D over C. Number C, we can also write that A over C, which means it's going to be P over D is equal to B over D. Then number 4, we have, we can have C over A is equal to D over B. We are writing our proportion, which we initially found, in many different ways. So this is basically the ratio and the proportion. Now to revise the triangle, the area of a triangle, we know that the area of a triangle, which is in this shape, and maybe it has a height here, and this is the base, the area of this triangle A, B, and C is equal to area of triangle ABC is always equal to half base times height. This is always our area. So always bear in mind that I was just recapping on that. Now I want us to start and look at the big things, which is the proportionality theorem. The proportion, my spelling, the proportion theorem. This is where the big thing is in grade 12 work. So now I want us to, I'm going to prove with you the proportion theorem. Okay, so in order for us to prove the proportion theorem, for instance, now let's say that the proportional theorem states that if a line is drawn parallel to one side of a triangle, it divides the other two sides in the same proportion. Okay, so we are saying that the proportion theorem states that if a line drawn parallel to one side of a triangle, so this is our triangle. Okay, this is my triangle. I have triangle A, I have triangle B, I also have triangle C. So now we are saying that according to proportion theorem, if a line is drawn parallel to one side of a triangle, so this is our For this case, I'll just take this one as one side of my triangle. So if I draw a line which is parallel to one side of a triangle, bear in mind that parallel lines, they will never meet, they will never intersect, they will never touch. So this is the parallel line which we're saying that if a line is drawn parallel to one side, so we can draw this parallel line. I'm drawing my parallel line here. This is parallel to one side of a triangle. Okay. Now it divides the other two sides. These other two sides, they are divided in the same proportion. In other words, the length of this and this and these two lengths, they are equivalent to each other. These two lengths, they are also equivalent to each other. So to re-say again my proportion theorem, it says that, oh my word, sorry for that. So my proportional theorem says that if a line is drawn parallel to one side of a triangle, so I drew my line here which is parallel to one side of a triangle, so they are both parallel to each other. Now, comma, don't forget your comma when they ask you in exam, state your prop theorem. Don't forget the comma, it's so important so that your statement can have sense. So we started by saying if a line is drawn parallel to the one side of the triangle, it divides the other two sides in the same proportion. So in other words, we are trying to say that if you're saying it has the same proportion, it actually means that these lines are equivalent to each other. These also lines, they are also equivalent to each other. So that's proportion theorem. So now I want us to prove the proportionality theorem. I want us to prove the proportionality theorem now. I want us to prove it so that you can understand it by proof. Okay, so now I have D and I have E here. Okay, so now this is called the prop theorem. Then you state the parallel lines. DE is parallel to BC. Okay, those are the parallel lines. So when you're giving a reason of using the prop theorem, you just write prop theorem, then you state your parallel line. So now, the first thing I want us to look is that I want us to check on the one thing which I want us to do now. So they are asking us to prove the prop theorem. So when you're proving the prop theorem, they want us to prove that AD over DB is equivalent to AE over EC. So how do we prove that? So the first thing we must do is to construct. So we start with construction. So what are we going to construct? We're going to first, let me just use a different, yes. So we're going to first join EB. Okay, so this is our EB. This is how you prove. It's always 6 mark in your exams. This is how you prove. You start by construction. What are we constructing? We are joining. We join EB. Just use B, alphabetical order. BE and CD. Okay. Then now we have to draw. No, I want us to draw heights. Must draw 2 heights now. So which height do you want to draw? Want to draw these 2 heights? Let me use a different marker so that you can see. So I want us to draw a different heights now. So I want us to draw this height. All right. And I also want us to draw this height. And when you're drawing a height, we know that our height is always perpendicular to the line which we have that side. So it must create 90 degrees. Your height must create a 90 degrees. So let me just name my heights here. Let me just name my height. Okay. Okay. Let me name this one. It's this one. Let me name it H1. This one, let me name it H2 so that you can see. Okay. This is my height 1. So now we draw heights H1 and H2. Those are our heights. Okay. All right. All right. All right. Now we are proving now. So now, let us look at triangle ADE. Triangle ADE. It has this height. Do you see that? Which is our height too. Okay, cool. Let's have our ball running now. Let's have it. Okay, so the first thing we're gonna prove using our areas. So we're gonna write that the area of triangle, let me check our triangle now, of triangle ADE over the area of triangle DBE over the area of triangle DBE is equal to, what is the area of triangle ADE? It's 1 over 2 AD. AD is the base, and our height is our H1. Okay, our height, it's our H1. All right. Okay, so it's half, the base is AD times height, which is H1, divided by half of the base. The base is DB times height. They are having the same height. So when we have and we understand the fact that according to our proportion of triangles, we know that the triangles, they have when they have the same height, when they are between parallel lines, they have the same height. So that's what's also important that we understand. So now this and this will cancel each other, this and that one also will cancel each other, and you'll finally be left with AD over DB. So we are done with the first one now. Do you see something is coming? AD over DB. Now I want us to do now, also again we do area. Now let's look at from this side using the height too. Area of triangle AED. Area of triangle AED divided by area of triangle ECD. So again, what is our base of triangle AED? The base is this one. So the base will be area of 1 over 2 base, which is AE, times our height 2, divided by half of the base, which is EC, times our height, which is H2. And you know this, they are the same, and this, and we'll end up having AE over EC. Do you see something? They're already equal. This is equivalent to this one. But how are we going to join them now? That's what's important. So in order for us to join them now, we have to write that area of triangle. Let's look carefully. Let's look carefully. Area of triangle, this one, ADE. Area, okay. Area of triangle ADE is the same, is equal to the area of triangle ADE. They have the same height. They are common, sorry. They are common. Now, also now, but the area of triangle, but the area of triangle ECD ECD. Wait, can I just double check something, please? Okay, the area of triangle ECD is equal to area of triangle I'll just check something first. All right, the area of triangle ECD. Where is ECD? ECD, this area is the same as the triangle of area of triangle DBE. Triangle DBE. Then they have the same base. That's the reason. Same base. They have the same height as well. So now we can conclude that the area of triangle ADE over area of triangle let's check DBE is equal to area of triangle, which is the other triangle which you're proving, AED over area of triangle. Which other triangle was it? Triangle ECD. Since we wrote that part here, so this part is the one which is assisting us here. So since we have this part, now we can conclude that these two areas which we are having here, they are equivalent to each other. So when they are the areas they equivalent to each other, then we can conclude now that AD over DB is equivalent to AE over EC. So that's our proportional theorem. That's our proportion theorem. Okay. Now I want us to just do a small example so that you can understand how we do and how we use the proportional theorem. Okay. So now, for instance, they will give you they will say determine X if PQ is parallel to BC. Okay, so this is the triangle parallel line. So we are having ABC and PQ. They are told us that it must be parallel like to BC. Then maybe let me put my X here. Let me put my 4 centimeters here. Let me put my 5 centimeters here. Let me put my 3 centimeters here. Okay, cool. Now they say determine the value of X. How can we determine the value of X? We are saying that PQ is parallel to BC, and we have just been taught about prop theorem. So what do? We know that the prop theorem says that we can write all proportions in different ways. So in this case, since we have everything here, so we can write that AP over PB is equivalent to which other side? AQ over QC. Why are you saying that? Why? Because it's prop theorem. And you state the parallel side. Then what is our AP? Our AP is 5 centimeters. Our PB is 3 centimeters. What is our AQ? It's 4 centimeters. Now we want the value of X. We know that according to maths, you cross multiply that thing, that what we have here, this and this will cancel each other. We have 5X is equal to 4 times 3 centimeters. We divide by 5, we divide by 5. Then we end up having X is equal to 12 over 5 centimeters, which is just the same as 2,4 centimeters. So I was just making a small example for you guys so that you can understand what's really going on prop theorem. So now I'm done with prop theorem. We have the similarity theorem now. Okay, so the similarity theorem, I'm not going to prove it. You can check it on your textbook as well. You have that one, but I'm just gonna state what it says. So on the similarity theorem, let's for instance, let's say we have let me do this. We have these two triangles, triangle D, E, and F. Okay. Then we also have triangle. We also have a small triangle this time. Triangle A, B, and C. Okay. So having triangle A, B, and C, we have 1, 2, 1, 2, and these two are not equal. It's an isosceles triangle, as you can see, and also the same applies with this one. Okay, so this is our two triangles. So now we are dealing about the similarity, and the similarity one, it's so essential. You must know it when you are writing your exams. You must know how to prove it by your head. All right. So now what does the similarity say? It says that if two triangles, we are having our two triangles here. So it says that if two triangles are equiangular, then the corresponding sides are in proportion, and therefore the triangles are similar. I'm going to repeat again. It states that if two triangles, just use a black pen, if these two triangles, this is triangle 1 and triangle 2, so we are saying that it states that if two triangles 1 and 2 are equiangular, then the corresponding sides are in proportion. Check it out. DE is the same as AB. The corresponding sides, they are in proportion. Look at DF is also equivalent to AC. Hope you see that. AC is equivalent to DF. Now, also, the corresponding angles, they are equivalent to each other. So now this D, we can see this D and A, they are equal. And we can also see that B and E, they are equal. We can also see that F and these ones are equal. So now we are trying to say that given triangle A, B, C, and triangle D, E, F. So what do we realize when we are talking about this similarity triangle? We are saying that if angle A is equal to angle D, and also angle B is equal to angle E, and angle E is equal to angle, and angle C is equal to angle F. Okay, do you see that? And also we can see that DE is equivalent to, let me check it out. DE is equivalent to AB. DE, this one is equivalent to this one. The corresponding sides are equivalent. So now we can now know that therefore AD, we can now say that, and we can now conclude that according to this similarity theorem which we have here, we can now conclude that no, we can know that AB over DE, you see, these corresponding sides are equal. So AB over DE, AB over DE is equal to, it's also equal to AC. Where is AC? We see our AC, AC and DF, they are corresponding to each other. So our AC over D over DF, all right, over DF, AC over DF, they are equivalent, they are in proportion with each other. Okay, so now that's our similarity triangles. You can just say, when you're asked the reason, you can just say the triangles are similar. Then you're done. They are similar triangles. Then that's that. Then you're done. Now, I want us to just vet and just to double check this, and I feel like you understand now the concept now. I talk about the proportionality theorem, and I spoke now about the similarity theorem. They are both important because they give us to what we want. Now, let's now look at our question paper, which I have here for like do 3 or 4 questions on this question. together so that we can understand the concept of what's going on. I'm gonna check from June. Let me check from June 2016. Now let's do the questions together. It's so nice. Please don't forget to drop your comment if you have any question. We are keen to assist. We are keen to interact with you as well. All right. So amazing. So amazing. That's your Euclidean geometry grade 12. Okay, let me just go through over these many questions which I have this side. I'm gonna just do 3 or 4 questions just for reference and just for you to get to know what we are talking about and the content. So I'm just gonna start from grade 11 because in your exams as well we're gonna start from grade 11. Bear in mind that it's always the case that even in grade 11 we start in grade 11. Okay, cool. Now please, I will urge you to look at Euclidean geometry grade 11. There is a video down there. I'll attach the link on the description of this video when we are done streaming. There is a video on Euclidean geometry part number 1. I urge you to look at it. It has all grade 11 core concepts, so you must have it. And now we have this side now, the grade 12 work, so that you can be able to bridge from grade 11 to grade 12. Right. So now let's check it out. Let's check it out. Let's check it out. Let's check it out together. Okay, now let's look on our question number 8. On question number 8, complete the following. Okay. On Euclidean geometry, whatever you write, make sure that you give a reason. Why are you saying that? Why are you saying that? Why are you saying that this angle is equivalent to this angle? This side is equal to this side. Why? You must always state the reason, because nothing just happens. There's always a reason for everything. Okay. Now let's look at our question number 8.1. Number 8.1. So on question number 8.1 is saying that complete the following statement. The opposite angles of a cyclic quadrilateral are. We know that according to theorem 5 of cyclic quads, 8.1, we know that the opposite angles of a cyclic quad, they are supplementary. They are supplementary. They are supplementary. So what do we mean when they are saying they are supplementary? They are equal to 180 degrees. They are both equal to 180 degrees. They are equal to equivalent to 180 degrees. Now, let's look at our question 2 here. 8.2. 8.2. 8.2. In the diagram, EF and EG are tangents to the circle. Where is EF? Oh, we have EF here. We also have EG. They are both tangent to the circle. We can see that they are tangent to the circle. A tangent, we say that a tangent, it touches the circle at one point. That's the tangent of the circle. Then we also have that the center is center O. So they are both tangent to the center O. Where is our center O? All right. Yeah, here is our center O. To the circle, it's center O. Now, FH, where is FH? FH is parallel to KE. Always, as I always say, that when you see the way I'm reading the statement, you read the first time, the second time, you read your statement, and after you're done reading, go check on your diagram. You read, now you're checking on your diagram. All right. And now we're given that angle H is equal to X. Now, the first question that prove that FOGE, where is FOGE? Prove that here's our F, O, G, all right, E is a cyclic quad. What you have to know is that you have to understand what is a cyclic quadrilateral. We know that a cyclic quadrilateral, about a cyclic quadrilateral, opposite angles of a cyclic quads, they are supplementary, which means they add up to 180 degrees. Okay. So how can we prove that F, O, G, and E gives us a cyclic quadrilateral? So that's not hard. We can see that it's not hard. Okay. So now we can see that E angle FO is equal to 90 degrees. The reason is radius perpendicular to the tangent. Okay. We were told that initially that EF and EG are tangent to the circle. So what does that mean? It means that this one and this one, they are tangent to the circle. So OF is perpendicular to the tangent, and when they are perpendicular, it means they form 90 degrees. So E, F, and O, it's equivalent to 90 degrees because the radius is perpendicular to the tangent. So when they are perpendicular to each other, they form an angle of 90 degrees. I hope everyone still remember that when every time 90 degrees is formed when the two lines are perpendicular to each other. Okay, so we are saying that the first one, which we are saying that EFO is equivalent to 90 degrees. Why? The reason is radius is perpendicular to the tangent. Also, as we can look that, we can also see that EGO is also equal to 90 degrees. They have the same reason that the radius is perpendicular to the tangent as well. Check it out. EF and EG, they are tangents, and any line drawn from the center of a circle to the circumference is a radius. So OG, it's radius in this case. OF is also a radius in this case. So which means these two lines, they are also equal to each other. So we are saying that OG is perpendicular to the tangent EG. So since it is perpendicular to the tangent EG, we must understand that when both of them since the both radius OG and OF are perpendicular to the tangent EG and EF, they create a 90-degree angle. They both create a 90-degree angle. So these two are equivalent to each other. Okay. Now we know that let's try to add both of them. (90 degrees plus 90 degrees, which is 180 degrees. So we say that the opposite angles of a cyclic quad, they are supplementary, they add up to 180 degrees. And we have seen that. So we can now conclude that therefore FOGE is a cyclic quad. Why are you saying that? Because the opposite angles are supplementary. Is there anyone with any question on how we found out that answer? Is there anyone with any question on how we found out that answer? All right, let's move on to our next question. 8.2.3 8.1.2. 8.1.2. All right, so on our 8.1.2 now, they are saying that prove that EG is a tangent to the circle GJK. Where is GJK? Just do this so that you can see big. Okay, so our question is saying prove that EG, where is EG? Oh, yes, EG. It is a tangent. Sorry, it is the tangent to a circle GJK. G, J, and K. Oh, this small triangle which we can form here. Here we can form a small circle. So we have now proven that EG is a tangent to that. So how do we prove that? How do we prove that? All right. Have you noticed that G1, angle G1 is equal to angle H is equal to angle X? Did you see that? It's Chord Theorem. This is from our previous video, which we have Euclidean geometry on grade 11. It's Chord Theorem, theorem number 7. So we are seeing that angle G1 here. We can check it out. This is G1. here. This is G1 and GF. You can see GF here. That's a chord. Then it's subtend to angle H, which is X. So we can see those two are equivalent to each other. And also we can see that angle, we can also see that we are seeing the parallel lines here. Do you see that? So when you're doing Euclidean geometry, don't hesitate. You can rotate your head like this. You can rotate your head like this so that you can be able to see your shape well. I also advise that if you have colors, bring forth your colors so that they can assist you when you are doing this kind of Euclidean geometry paper too. So now, these two parallel lines, F and H, they are parallel to E and EK. So what do we know about parallel lines? We know that parallel lines, they have corresponding angles, they are alternating angles, they are co-interior angles. So now let's check really out. Do we see that angle H is equivalent to angle AK? Because they are corresponding angles. They form a letter K, a letter F, sorry. So now we can also write down and depict that. We can also write down and depict that angle H is equal to angle K is equal to angle S because they are corresponding angles. And when you have corresponding angles, you always state your parallel lines. EK is parallel to FH. Okay. So now we can therefore conclude that angle G1 is equal to angle K. Do you see that? Because they are both equal to X. Okay. So now we can now conclude that we can now conclude that KG is a tangent. Why are we saying EG is a tangent? Because angle between line and chord. Okay. Always know that if you are being asked to prove something, always know that there are what is we call the Convex Theorem. Also, please be aware of how to use the Convex Theorem. So this is how we prove that. So we can see that this is our EG. Our EG was here. This is our G. This is our E. And this was our G1. We had something like this. And we also have our K here. So we can see that this angle is equal to this angle because they are both equal to X. So since these two are equal, so therefore this is a tangent. You know that the tan chord theorem say that this angle is equal to this angle and this angle. This is now the new chord. This is now the chord which you are using, and it will be equal to this angle. So that's the tan chord theorem. So that's how we were gonna prove that question. Anyone with any question? Okay, now let's proceed to the last question. So the last question which we are having here is that they are asking us prove that FEG, where is FEG? Where is E? FE, okay. FEG, okay, FEG, yes, I can see that. Prove that FEG is equal to 180 degrees minus 2x. That one is not hard. That one we cannot see it as hard because bear in mind that O1 is equal to 2h. Do you see that? O1 is equal to 2h. O1 is equal to 2h. So that won't be much hard for us. So how can we see that? We can just write now on 8.1.3. So we know that we are proving that these are equivalent to 180 minus 2x. So we can see that angle O1 is equal to 2h. Why? Angles at the center are equal to twice angles at the circumference. Okay. Theorem number 3. Always know your theorems so that you can be helped. Okay. So we are saying that angle at center is equal to 2 times angle at the circumference. Do you see that? So now we can now therefore what was our H? Our A was X. So we see that angle O1 is equal to 2x. Where is O1? So that you can see it. O1 is equal to 2x. Do you see that? O1 is equal to 2x. So now they just want us to prove that FEG, where is E? This is our E. This is the angle E, which we are seeing here. And do you still remember on our first question, they proved us to prove that FOGE is a cyclic quadrilateral. So now we can see that our angle O1 here, it's 2x, and we know that FOG and E is a cyclic quadrilateral, and we know that cyclic quadrilateral, they are the opposite angles of the cyclic quad. They give us 180. So now let's add O1 plus E is equal to 180 degrees, because they are opposite angles of a cyclic quad. So we're going to have angle O1 plus angle FEG is equal to 180 degrees. What's your reason? Because opposite angles are opposite angles of a cyclic quad. That's your reason. That's opposite angles of a cyclic quad. So we say that is 2x plus FEG equal to 180 degrees. Now we make FEG the subject of the formula by transposing 2x. Then we can see that we have proven what we were asked. Is there anyone with any question? You must get relevant to your grade 11 theorems. They are so important. They are very, very, very important. They are very, very important. Now I want us to do question 10. I want us to do question 10. Something which is a bit challenging. Yeah, it's not that challenging, but yeah. Great. Now, in the diagram below, triangle ABC. Oh my word, this is what we are doing right now. Triangle ABC is drawn with DE parallel to BC. Then the first statement, they say, complete the following statement. A line drawn to one side of a triangle divides the other two sides in. Then you have to finish that one. As I've already stated for you guys initially, they are divided, those two other sides of a triangle are divided in proportion. So the only word which I have to add only there is in proportion. So you just have to know your theorem in head. So a line drawn parallel to one side of a triangle divides the other two sides in proportion. It divides the other two sides in proportion, just like what we did right now. Now they are now saying that use this theorem and prove that AD, where is our AD? AD over DB is equal to AE over EC. So how do you prove that? You prove that by the same method which we did earlier on. We say that we look at our both triangles, and now they've already constructed heights for us, so that's easy for us. So what do? We start by looking at the area, or we just try by start by construction, and we join DC and EB. Then after that, we can now say that the area, when we are proving, we say by saying the area of triangle ADE. Let me just do it fast for you guys. So we say that we start by construction. Just do this so that you can be able to see. Let's try to do it fast. At least now they draw everything for us. Okay. So we start by saying we have to do construction, because they didn't do construction for us. Construction. And what are we doing on our construction? We are joining DC and BE. So we join them. So in other words, we will have something like this. Let me just draw a sketch first. And they told us we have this height. We also have this height, 90, 90, AD, BEC. Then now we must join these two lines now. Okay. So this is the small triangle which I just drew. So what is the proof now? Let's prove for 6 marks. So the first thing, we know that, as we have highlighted already, that the area of triangle ADE over the area of triangle BDE, it will be, so we know that area of a triangle is half base. What is our base this time? It's AD, and our height, it was H. Okay. Then we have half also the area, the base of triangle BDE, it's BD, and also they have the same height. Then now we can end up having AD over BD. We have already proved this, but let me just recap it quickly for you. Okay. Now also we know that the area of triangle AECAE, now the next one, we know that the area of triangle ADE, or we can just say area of triangle AED over the area of triangle ECD. Okay, over the area of triangle ECD. Just do that. DE. So we know that it's gonna be half base, and our area there we have DE times, AE. Okay, let's just write it in this way so that we don't get confused. AED and ECD. All right, so we're gonna have the base here is gonna be AE, so half AE, which is the base, times the height, which is K, and we also have 1 over 2. What is the base? The base is EC times the height C. Do you see that the heights are the same? So we then now we can cancel this and this, this and this, then you end up having AE over EC. Okay, then now we are not yet done, but this part is so important. But always note this part is so important. But okay, but area of triangle BDE is equal to the area of triangle CED. Okay, because the reason is they have the same base and height. So those two triangles, they have the same base and the same height, so they are equal to each other. So now we can be able to conclude that area of triangle ADE over area of triangle DB of triangle DBE. Is it DBE? Just double check. Oh, area of triangle ADE and area of triangle BDE. Yeah, it's the same thing. Is the equivalent to area of triangle AED over area of triangle, which is other triangle, ECD. Then now therefore we can conclude that AD over DB is equivalent to AE over EC. They are equivalent to each other. So that's your proof. You must know your proof by head. You must know it. But and also I advise that you can memorize it, but it's not advisable. You must know it and be able to understand it on your own. Don't memorize it. It will confuse you. Okay. Don't memorize it. It will confuse you. Don't memorize it. It will confuse you. All right. So this is our proof. Now our next question here is saying that we are given that triangle this is something relevant to something which we are doing right now. 10.2. They are saying now in triangle PQR, where is triangle PQR? That's the big triangle. On PQ, okay, on PQ we have V in a point in triangle PQR, T is on point PQ, V is a point on PR. Do you see that it is a point on PR, and TVRW is a parallelogram? We are given that it's PT, it's x plus 2. We are also given that QT, it's 15. We are also given that PV, it's something which are not given. Now they are saying calculate the value of x. How do you calculate the value of x? How can we calculate the value of x? So you can see that we are just smelling the proportionality theorem here. So what do we do? Now let's do and write our proportion in order. So we can see that QT of TP is the same as, look at our parallel lines, please don't lose the parallel lines. This is the same as QW over WR. What is our reason? Prop theorem. Then we state the parallel side. Which one is our parallel side? TW is parallel to VR. Okay, now let's substitute. So when we are substituting now, it's going to be 15 over x plus 2 equal to x plus 4 over x. Okay, I hope everyone can see this clearly. Must take note of our prop theorem, guys. I hope you can see this. So you can take your face, if you can't see, and just do this. You can now see the triangle, the big triangle. When you're looking at the big triangle, it's now QRP, okay, and the parallel line, it's TW is parallel to PR. So we can be able to calculate our parallel to VR, sorry. So now we can be able to calculate our equation which we're given here. Okay, now let's solve for x. Everyone knows that we cross multiply there, then we have 15x, then we have x plus 2 and x plus 4. Then you apply your skills of algebra. We know that 15x, then that will be x squared plus 4x plus 2x, that's plus 6x. 2 times 4, that's 8. Then now we're solving for x, so we're gonna have 8x squared. Then we transpose 15x to this side, so it's gonna be 6x minus 15. 6 minus 15, 6 minus 15, that's 9x, but it will be negative 9x plus 8 is equal to 0. We look for our factors. So we look for factors. We know how to look for our factors. We did a video solving for x. You'll be able to connect on that. And we have x minus 1 as well. Then now we can now there conclude that therefore x is equal to 8 or x is equivalent to 1. All right. So those are two values of x which we have here. Those are the two values of x which we have here, right? Oh, we're not done. This is my last question today. This is my last question which I'm doing right now. Okay, if VR is equal to 10 units, where is VR? Okay, if VR is equal to 10 units and x is greater than 1, determine the value of PV. Oh, that's easy. Again, we're going to use our prop theorem. Check out and look that we have PV. Yeah, we have PV over VR, which is equivalent to PT over TQ. You can check that out. We are saying that PV over VR is equivalent to PT over TQ. You can see that. What's your reason? Your reason always is prop theorem. And now you state your parallel sides, which is TV. As we can see that TV is parallel to QR. Then now we substitute, okay? We want PV, but we know our VR that it's 18. Our VR it's 18, okay? Which is equal to 10 over 15. Then we cross multiply again. It's going to be 15 PV is equal to 18 times 10. Then we divide both sides by 15. Then we end up having our PV to be equal to 12 units. To be equivalent to 12. Oh, sorry. Yes, let me just start again. So we have PV over VR is equal to PT over TQ. That's the prop theorem, provided that TV is parallel to QR. So those two, we can see that they are having parallel lines. So we can now substitute and having PV over VR, which is 18 and 10 over 15. Then we do what we do best and we are able to solve the equation. Now we'll be able to solve the equation. Let's do this question 11 because it has something which is important, which is the similarity theorem which we're doing. Question 11. Question 11. This is the last question of the day. Let's do question 11. It is something which we are doing. Now, given O is the center of the circle, BA is perpendicular to AC. Where is BA? BA. Oh, that's BA. BA is perpendicular to AC. We can see that really they are perpendicular to each other because of that angle of 90 degrees, which is there at A. Okay, and D is the midpoint of A of BC, which means angle D1 and D2, they are equivalent to each other because they line OD bisect the chord BC. Now prove that triangle ABC is equal to triangle DOC. Where is triangle ABC? Let's check it out together. Triangle ABC is equivalent to triangle DOC. Okay, prove that triangle ABC is equal to ABC. The big triangle is equivalent to the smaller triangle DOC. Okay. Do we see that something there? Do we see that angle C is common in both triangles? So how do you do that? Always you start by writing down so that the marker or your examiner will see, exam marker will see that you know what you're doing. So let's try by saying in triangle ABC and triangle DOC. What do we see here? Number one, we see that angle C is equal to angle C is equal to why? These two angles, this angle C and this C, they are common in both triangles. You've already been given a mark by just stating that they are common. You are done. You have your mark. Now, number two, what else do we see? Do we see that we are told that angle A is 90 degrees? Do we see that angle A is 90 degrees? Which means we already have something from triangle A. Now let's check it something from triangle DOC. Do we see that angle D2 is also equal to 90 degrees? Because bear in mind that we say that D is formed as a result of OD bisecting chord BC. So we can also conclude that angle A is equal to angle D2. Angle A is equal to angle D2 because both of them they're equal to 90 degrees. Both of them, they're equal to 90 degrees. So since now we have already seen these two that they are both equal to 90 degrees, so now we can definitely conclude because we really don't care about the other last one, B, angle B and angle O. We really don't care about it. At least you have two reasons which are so important and so solid. So now you can now conclude that triangle ABC is similar to triangle DOC. We know that. What is the reason inside? The reason is what is important. It's angle. Others will write angle, and angle. So you're done proving. So that's how you prove the similarity in that instant which we have above. That's how you prove the similarity in that instant which we have above. Now show that OC. Is equal to DC times BC over AC. Did you realize? Let me just do this with you guys. I want us to see something saying so that OC is equal to DC times BC over AC. I want to tell you something. When you see something like they're just trying to confuse what you know already. Let's do the right thing here. Okay, when we have OC times AC, it will be equivalent to DC times BC. Okay, so we can divide both sides by BC, so we can have OC over BC, and we can divide that side by AC, we have DC over AC. Do you see that? So that's basically what they want here, but nonetheless, they want us to prove this. And how are we going to prove this, guys? So in our first question, we were told that these two triangles are similar to each other. So now we can see that OC, now we can use what we have from our similarity triangle, that OC over BC. Do you see something? I want you to be careful of this thing. OC is here, BC is also here. These two, they are equivalent to DC, which means also over A over AC. Just change something. AC over DC over AC. Do you see that? Then now, what is our reason? The reason is that the triangles are similar to each other. So you can just say that triangle ABC is similar to triangle DOC. Then you're done. Then after that, you cross multiply. Then you end up having OC is equal to DC times BC over AC. Then you're done with that one. Let me check the last one now. The last one, given that DC is equal to X and AB is equal to 10, calculate the length of OC. Oh my word. Calculate the length of OC. Where is OC? Given that AB is 10 and we are also given that DC it's X. Calculate the length of OC. Oh, okay. Let's just do the old school in grade 10. We were taught that according to the Pythagorean Theorem, and we can see that triangle that ABC. Okay, let me just say in triangle ABC so that you can see what you're talking about. In triangle ABC, we can see that AC squared, according to the rules of Pythagorean, AC squared plus AB squared is equal to BC squared. Okay, then what's its Pythagoras? Okay, so now we want AC. Okay, so we can determine AC squared by saying that is BC squared minus AC squared. Then our AC will be equal to the square root of BC squared. What is our BC squared, guys? Our BC is 30 squared minus our AC squared. What is our AC? Our AC is 18 squared. So therefore AC will be equal to, now we use our calculator. When you use your calculator, what do you get? When you use your calculator, what do you get? When you use your calculator, what do you get there? So we are saying that the square root of 30 squared, let me just choose my calculator as well, 30 squared minus 18 squared. Okay, square root of 30 squared minus 30 squared minus 18 squared. Okay, then our answer is 24. When you use your calculator, you get 24 units. Okay, so after I've got that 24 units, we are not done with what we are supposed to find. Then now we need OC. Now at least we know AC, we know DC, we also know BC. So now we can now say OC is equal to, what is our DC? Our DC times BC over AC. Okay, we know that our DC is 15 times 30. I hope everyone can see my screen. Yes, it's 15 times 30 divided by 24. Then we have the equivalent answer, which is 18.8 centimeters. Okay, so that is our final answer. I hope you enjoyed this session. We were doing Euclidean geometry grade 12. I hope everyone enjoyed every second which we have. I hope everyone enjoyed. At 5:45, we'll be doing a controlled test term 1 for maths, which comprises of the number pattern as well as Euclidean geometry. I've already set a question paper for you guys, so please also do tune in 5:45 so that we can just do it. It's going to be a 15-minute session that we just do together and redo that question paper. And I wish everyone is going to write their control tests this week and next week. I wish you all the best. So for now, just take your break, 5 minutes, 10 minutes break, because at 2:45 we'll be live again to do this control test for 15 minutes to 20 minutes. So take a break, go out and eat, have a drink. Till we meet again, have a blessed break. Thank you.